Now today we're going to be working with solving equations with grouping symbols. So by the end of the lesson we're hoping to be able to say I can solve equations with variables even when there are grouping symbols. So in number 1, if you notice, you have variables on both sides of the equation just like we had yesterday. But the new thing today is that we see parentheses. So if you look at your checklist for solving linear equations and inequalities that we gave you, let's start with step 1. It says distribute a common denominator to remove fractions. Well, we don't have any fractions in here, so let's skip step number 1. And it says remove any parentheses on the left of the equal sign. There are not any there, so skip step number 2. Number 3 says remove any parentheses on the right-hand side of the parentheses. Okay? So let's do that. Let's distribute so we can get rid of our parentheses. 5 times h and minus 5 times 2, which is 10. And of course, we have to bring down on the right side what we already have. So that's step 3. Number 4 says combine like terms on the left. There is nothing to combine. Step 5 says combine like terms on the right. There is nothing to combine. Number 6, step number 6 says like variable terms that appear on opposite sides get combined by moving one of those terms to the other side. Basically, this is what we did yesterday. Okay, if we have variables on both sides of the equation, you got to get all your variables, all your h's, to one side. So I like to take the smaller one and get rid of it. So I'm going to subtract 3h from both sides of my equation, both sides of the equal sign. 3h minus 3h is just 0 equals 5h minus 3h is going to be 2h. And of course, we still have minus 10 over here. So right now we've got all our h's on one side. Let's get all our other numbers off of the side with the h. So you have a minus 10. We need to add 10. Of course, we need to do that over here as well to balance our equation. So 10 equals 2h. My last step should be obvious by now, guys. In order to get that h by itself, you got to divide by 2. And we're left with h equals 5. Folks, the directions say to check. You should take this, put them back in up here. 3 times h is 15, so the left side has 15. Let's see what the right side equals. What is 5 minus 2? That's 3. 5 times 3 is 15. Guess what? Both of your sides are the same, so your answer checks. You guys should show the check. I'm only not doing it for time's sake. I don't want you to have a 20-minute video. Alright, let's jump to number 2. This one's going to be a lot of fun. Let's go back to our checklist if you're not sure where to start. Step number 1 says distribute a common denominator to remove fractions. There are no fractions, so we're going to skip that. Number 2 says remove any parentheses on the left. When it says remove, it means, hey, if you can distribute it all, let's do it. So 2a minus 2 times 8, which is 16, and you still have plus 7 right there, equals, step 3 says remove any parentheses on the right. So let's distribute over here. 5 times a is 5a, 5 times 2 is 10, then you still have minus 3a minus 19. Okay, we've gotten rid of all of our parentheses. Step 4 says combine like terms on the left. So you have 2a, but then you have minus 16 plus 7. So altogether that should be a minus 9, or a, if you guys like to write it as a plus a negative 9. Equals, my like terms over here should be pretty obvious, 5a and negative 3a. So 5a plus a negative 3a is going to be 2a. And then you have a positive 10 and a negative, here I'll change that for you, add the opposite. 10 plus negative 19 is going to be minus a 9, or plus a negative 9. Now, you're seeing something here that's kind of strange. If you notice, you literally have the exact same thing on the left-hand side that you have on the right-hand side. Yesterday, we actually talked on this just a little bit. If you got down to the very end, and let's say you decide to subtract 2a from both sides because you're trying to get all your a's onto one side. Well, when you subtract 2a, what happens is that you're left with no variables. But what we have here is a true statement. So yesterday, like I said, we touched on it. Since this is a true statement, it means that you can literally plug in any number for a in the original equation. And your left side is going to equal your right side. So that means, since this is a true statement, our solution is all real numbers. Okay? Any number you can think of would satisfy this equation. Okay? All real numbers. Remember, if these two things are not equal, so if this statement right here is false once you get rid of all your variables, then that means there are no solutions. That means you can't find a single number to plug in for a that would make the left side equal to the right side. Alright, number 3 I'm going to ask that you guys do on your own. So please have that for me tomorrow. Number 4, let's move on here. This is another interesting one, so pay close attention. 2 is very special. 4 is also very special. So here we do have fractions, but there's nothing to distribute. So we're going to skip step 1. Step 2 says remove any parentheses, and as well as step 3. We don't have any, so we're going to skip steps 2 and 3. Step 4, combine like terms. Don't have any, don't have any. Step 6, here we are. Let's try and get all our variables onto the same side. So I'm going to subtract 3x from both sides. La-di-da. 3x minus 3x is 0. But on the left side, we should still have a positive 1/3. Of course, that's going to equal. And then we have 3x minus a 3x is 0. And then we have a negative 1/2. Okay, what do we see here, people? We're seeing that we got rid of our variables, and you should double check your work to make sure you did it correctly, or triple check it. But once you realize that yes, you have done it correctly, and you have a false statement right here, I'll write this here just as a reminder, since this is false, your answer should be no solution. There is not a single solution for x that you could come up with that would make this equation true. No solution. Alright, let's pop onto our last slide here. And let's start on number 6. I'm going to ask you to attempt number 5 on your own. That one should be a lot of fun. Take your time. Enjoy it. Enjoy the process. Use your checklist and see what you can do. We'll talk about it in class tomorrow. Number 6. This is an interesting one. Okay? We have two fractions, and we have expressions on top of numbers. So we have a numerator that's an expression, and we have a denominator that's just a number. So this is probably different than we've ever seen. Let's look back. Since we're solving an equation, let's still use our checklist. It works every time when you're solving an equation. Number 1 says distribute a common denominator to remove the fractions. It says in parentheses, this step can be done later, but it makes the equation easier to manipulate if you get rid of your fractions now. You guys are always complaining to me that you do not like fractions. So if you can eliminate fractions, if you can eliminate denominators and just work with regular numbers, why wouldn't you do it? Here's the trick, guys. If you have a fraction, actually, if you have any number of fractions in your equation, all you have to do is find a common denominator and multiply both sides of your equation by that number. So in 6's case, the common denominator, 12 and 4, or the common multiple, is going to be 12. What that means is both 12 goes into 12 and 4 goes into 12. And that's the smallest number that they both go into. Okay? The least common multiple. The reason we're multiplying by 12 on both sides is because watch what happens. You're multiplying by 12 over 1 on both sides. Do you remember when we worked with fractions? And I'll show you an example here, like 2 over 3 times, 6 over 8. When we worked with multiplying fractions, there was this thing called cross cancellation. So before you multiplied and got big numbers, you could simplify this. You would always tell me, hey, 2 goes into 2 one time, and 2 goes into 8 4 times. So I'm allowed to reduce those two. Oh, and 3 and 6 have something in common as well. 3 goes into 3 one time, and 3 goes into 6 two times. So now I have really small numbers, and I can just multiply 1 times 2 is 2, and 1 times 4 is 4, and of course that equals 1/2. Okay, but that kind of looks silly right now because we're using such small numbers. But when we use really big numbers, you guys found it a lot easier when you were able to cancel things out and work with the smaller numbers. That way you didn't have to use a calculator. Well, the same thing's true here. We don't want to work with fractions. So if I multiply by 12 on the left side, or 12 over 1, it's the same thing. I have one fraction, and let me switch colors here. I have one fraction here, 12 over 1, and I have another fraction right here. So let's do our cross cancellation. 12 goes into 12 one time, 12 goes into 12 one time. So now all I have left is 1 times a minus 6, and on the bottom I just have 1 times 1. So really it's a minus 6 over top of 1, which I don't really even need to write. Now over on the right side, the reason it's important to multiply by 12 is because 4 also goes into 12. So you need something that 4 will go into so that you can cross cancel. How many times does 4 go into 4? It goes in there once. How many times does 4 go into 12? It goes in there 3 times. Look what happened to our denominators. You now just have 1 times 1, so you don't even have a denominator. What do you have left on top? You have 3 times this whole quantity, a minus 2. 3 times a minus 2. That's all you have left. You just got rid of your denominators, and this is now way easier to work with because you don't have fractions. Okay, that's why step 1 in our checklist is so important when we're dealing with fractions. Okay? Now, step 2 says remove any parentheses on the left. We don't have any. Skip it. Step 3 says remove any parentheses on the right. All right, let's distribute. So 3 times a is 3a, and 3 times 2 is 6. Of course, we still have a minus 6 over here. Let's continue. Combine like terms, don't have any. Combine like terms, don't have any. Step 6, let's get all our variables on the same side. So I'm going to subtract 1a from both sides. A minus a is 0. I'm left with negative 6, because that's plus a negative 6, equals 3a minus 1a is 2a minus 6. Now I have all my variables on one side. I want to start by eliminating the thing that's not attached to my a. So since we have minus 6, I need to add 6. When I do that, what happens? Negative 6 plus 6 is 0. And of course, I'm left with 2a. Is a by itself yet? No, it's not. So you must divide by 2. What is 0 divided by 2? 0 divided by 2, 0 divided by 7, 0 divided by a billion. Doesn't matter. That answer is 0. So a happens to equal 0. You can always check this. Let's take it back up to the top, to our original equation. Plug in 0 for a. What is 0 minus 6? It's negative 6. And of course, that's still over 12 in our original equation. And let's take it to the other side. 0 minus 2 is negative 2. And of course, that's over top of 4. Well, guess what? When you reduce your fractions, negative 6 over 12 is negative 1/2. And negative 2 over 4 is negative 1/2. So guess what? You got a true statement. That means your answer checks. That means you're done. Folks, the summary is just this. This mental checklist. Oh, I was definitely meaning to underline that. I apologize. This mental checklist is so very important. You should be asking yourself these. You should be going through this same process every time you solve an equation. All right, you got a few that you're supposed to do on your own. I look forward to seeing you tomorrow.